Welcome to my YouTube channel, Techie Sang.
Criteria for selecting a processor is that million instructions per second performance or flops, whatever might be the thing, whichever is required according to the application requirement. You have to see the performance and you have to select it. First thing. Second thing is power. Whether it is battery operated or not. If it is battery operated, you have to design the system in such a way that it consumes less power. Okay. And you have to choose whether the architecture you want RISC architecture or CISC architecture. Reduced instruction set architecture or complex instruction set architecture, whichever that you want to use it, that you have to select it accordingly with respect to instruction set architecture. The input-output interfaces that is required are UART, SPI, I2C. Okay, there are other things also. You can use it for input-output interfaces. Okay. You can, according to that, you can select the buses. Real-time capability. Whether your application is need to be run in real time or not. That has to be decided. That is a problem in selecting a processor. In selecting a processor, these are the main things that plays a vital role. Cost and availability. If it is a toy, in that case, you can just use 8-bit processor. With small memory, you can use it. The cost will be very cheap. And you can use it. And you will have availability also. Availability of the processor will also be there. Okay. If it is a sophisticated system, in that case, the cost will be very high. And the availability of the processor, you have to check it. And you have to see for support tools whether it is available. And development environment, you have to check for the development environment. These are the criteria for your processor selection. Memory in embedded system. Memory stores program code, data, and input-output buffers. If it is a memory, we know that you can very well say that it is read-only memory, random access memory, cache memory, electrically erasable programmable read-only memory, or flash. Okay. If it is read-only memory, it stores in firmware. It lies in firmware. It is random. If it is random access memory, it is a volatile memory. Okay. Whatever data in runtime, that will be stored in random access memory. Once the system power is switched off, the runtime of that corresponding program, the data will be deleted because it is volatile memory. Once the power is switched off, all the data will get erased. Next is to speed up the processor, that is to boost the performance of the processor. In that case, you have to go for cache memory. To boost the performance of the processor, in that case, you have to go for cache memory. Okay. That is all intermediate results that is executed by your CPU that will be stored in the cache memory and you can retrieve it easily instead of getting the data from the main memory. Okay, the speed cycle will be reduced, clock cycle will be reduced, so it boosts the performance. EEPROM or flash This is for persistent storage. Types of memory devices. ROM types, if it is read-only memory, there are different types. Maskable read-only memory, programmable read-only memory, electrically programmable read-only memory, electrically erasable programmable read-only memory, and flash. These are the types of ROM memory. In case of RAM type, it is static RAM or dynamic RAM. Static RAM is made up of flip-flops and dynamic RAM is made up of capacitors. Okay. There are a lot of differences. It is cost effective and depending upon how the data is stored, it is compact size in case of dynamic memory. It takes space, it occupies space in case of static memory because it uses flip-flops. Okay, these are difference between static memory and dynamic memory. Other than that, you have internal as well as external memory. And the considerations you have to take care is that if it is memory, first thing that you have to see is size. And next thing that you have to do is speed, volatility, and cost. So you have to see ROM types, RAM types, internal or external memory considerations. Under considerations, you have size, speed, volatility, and cost. Criteria for selecting memory devices. Memory size required is port size or buffer size. And then access time or speed. Power consumption, volatility, cost, and packaging, compatibility with processor architecture. Okay. Access time is that once you feed the time required to take the data, that is access time, and you will calculate that one as speed. Power consumption. If it is a more product that you're going to design using embedded system, you have to calculate how much power it consumes. Based on that, you will be using the battery, whether it is battery power or it is powered directly. That you have to calculate it before releasing the product. And the memory, wherever the data, once the data is not repeated for next stages, in that case, you can go for volatile memory. Otherwise, you have to go for non-volatile memory. You have to decide where you have to use volatile memory and where you have to use non-volatile memory. Packaging as well as the cost that you have to calculate it. And compatibility with the processor architecture. Now, whatever the memory you choose it, that should be compatible with the memory, with the processor architecture. That is more important. Processor memory interface. Okay, you can interface the processor as well as the memory with bus. The bus width can be 8-bit, 16-bit, or 32-bit. The bus width can be 8-bit, 16-bit, or 32-bit. You have address and data buses. Address and data buses. It can be a memory mapped access or it can be input-output mapped access. And if you want to transfer the data directly from memory to CPU, in that case, you have to go for direct memory access. Okay. Whether you require support for high speed transfers or not, that you have to select. And the trade-offs in selection is that, first thing is that you have to select performance versus power, because high-speed device will take more power. High-speed device will take more power, but the cost will be high and the features will also be more, and the size of memory you require may be more. So if memory size is big, speed will be less. And you have on-chip versus off-chip memory, whether you have to go for on-chip memory or whether you have to go for off-chip memory. So the first trade-off is performance versus power. And next thing is cost versus features. If cost increases, features decreases, features also increases. Memory size versus speed, on-chip or off.
Thank you, friends.